Okay, so let's move on to the next exercise. So I have the exercises. No, here. Okay. So the next exercise is that we need to compute pi using this equation here. So this equation is invented by an Indian mathematician called Ramanujan, probably pronounced a little bit wrong, who lived in India and is very famous for coming up with a number of very spectacular results, even though he didn't have formal training in math. So a very famous character in mathematics. And he came up with this relationship where the 1 divided by pi is equal to what we have here on the right hand side. And we want to implement this as a mechanism for computing pi. So of course what we have here is an infinite sum. So it starts at k equal to 0 and then it goes up to infinite. But as you can see, all the terms in the sum are positive. So we can conclude that these terms must become smaller and smaller and smaller as k increases. So in fact we can approximate this sum very exactly by having a finite number of terms. How many? Well, we need to come up with that with some experimentation, so I'll leave that for when we try to solve the exercise. So what's the strategy going to be? I think the strategy here is going to be that we start with the loop, and we start by trying to compute the sum part. Then we multiply it with these constants, and then in order to get pi, we need to compute the inverse of all of this, like 1 divided by all of this stuff over here. So I think that's going to be the strategy for this exercise. So here's the Ramanujan function that should return pi, and we have a little bit of an example of how it can be called down here. So let's let's include that, and then just to make the code work, I'm going to return -1 here. And now we can see that it approximates pi, but maybe not extremely well. So how can we do that? Let's start by defining the sum as s equal to 0. And now we need a loop over k, from k equal to 0 up to infinite. So let's do a while loop. And I'm actually going to start by defining k, and then let's say while k is equal to 2, and then say k equal to k plus 1. Because now, if I look at what value k has, it'll increase. So I need to do something more here. I need to somehow stop the loop at some point. But now I've gotten so far that I define k, and it grows. And how did I do this? Hide terminal. No, kill. Okay, that felt good. Okay, so in order to avoid that, I think we'll stop k in the first iteration. Okay, so that took care of the sum, and it took care of defining k. So let's start by defining each term inside the sum, and let's call that for term. That's a nice way of naming it. So we need to compute 4 times k and then the factorial, which is like all the numbers up to 4k multiplied with each other. You can do that using math.factorial. And again, you can use VS Code to figure out how to do factorial, because autocomplete will tell you. So we do factorial of 4 times k. Then we need to multiply that with this stuff. Oh, I wish I could copy paste. Can't I copy paste somehow? Maybe I can. Ooh, this is convenient. Good. This feels good. Yeah, let's do a little bit of copy paste here. So we need to multiply that with this stuff. And I guess we need a multiply sign here. And that took care of the denominator. And then we need the denominator, and that is k factorial raised to the power of 4. Like, it's a really odd expression. Factorial of k raised to the power of 4. Remember, we can compute raised to the power of something using double multiplication signs. Let me just actually put a parenthesis here. I think that's nice in order to know what's grouped with what. and then we multiply that by 396 raised to the power of 4k. And I have no idea why this is true. So raised to the power of 4k, I'm going to put a parenthesis here. I really like to add a lot of parentheses when I'm writing expressions like this, because I know that you can read the book really carefully to figure out how Python automatically evaluates these expressions, but I'm in favor of just adding a lot of parentheses and being sure. So that computes this term. So let's do then print out the kth term of the sum is, and then write out term like this. So now when we run the code, let's actually write out what k is. So k. So now we should print out both what k is and what the term is. So the first term is 1103. Interesting. Let's do a couple of additional terms. So instead of breaking here, let's do if k is greater than or equal to 2 break. So that should give us the first couple of terms. So k equal to 1 and k equal to 0 and k equal to 1. So we can see that these terms quickly become smaller. So let's actually do a couple more. Now we can see they become very, very, very small, very, very quickly. In other words, maybe we feel that it's okay to just have a few of these terms involved in the sum. Okay, so I'm actually not doing anything with the terms yet, but let's start to add them to the sum, and that will give us the sum out here. Oops, I forgot to add the right term to the sum. So now we aggregate all of these terms to the sum, and that means that we actually get an evaluation of this expression here. Okay, so I said earlier that I wanted to show the debugger, and I guess I might as well just start to do that now. So the way I show the debugger is that first of all you need to be aware that the debugger exists as a different run option than the normal running of a file. So right now we have the normal array, and we want to select this one here that I can access using the drop-down menu. So what does the debugger do? Well, if I go into the margin, you'll see that Visual Studio Code automatically highlights the line with this little red dot. So let's say that I select a line and I press it now. I just left click here. It puts a dot. And I can also put a dot here, and I can put a dot here, and I can even put a dot here and a dot here. Okay, and I can remove the dots again by clicking on them again. So I can insert and remove dots however I want. Okay, so this is what the debugger does. If I go up here now and I select, okay, let me show you what happens if I just run it normally. Nothing. It does whatever it did before. But when I select the debugger, it starts up, and then you can see that there is a yellow arrow now, and it highlights this line. What has happened here, and we also have a little palette up here. What has actually happened here is that the Python started to run, and it ran and it ran. It saw there was a function definition. Okay, fine, there's a function. I keep running. I reach this line, and then it saw there was a dot. And then it stops on the dot. So Python is right now completely stopped on this line. And what I can actually do now is I can press debug console. So notice this is different than the terminal. And then I can start to just write out variables that are defined within the script. So it's like a frozen time during execution, and now I can experiment. So I can do stuff like this. I can concatenate game with something. Really? Like this. And it just works. I can like really examine everything that goes on. I can also do mouse over, and it'll show me what value the variable has. It also, but I use these relatively less, it shows me a little bit of information about where I stopped inside the script. But I tend to use these features less. But we can look at them a little when we get more into the script. Okay, so this alone is not super convenient right now because, okay, fine, I could probably know this using experimentation. But notice that I have this button here called continue, and it has a shortcut F5 on your keyboard. If I press continue, it starts running again, like the time unfreezes, and then it runs until it reaches the next breakpoint, which is this one. So now Python is here. And then when I press continue, it will continue running the script, and what it will go to do is that it will call the Ramanujan function. Go into the Ramanujan function, and then it will hit this breakpoint up here. So now we're here. And if I continue again, we go down here. And now you can see that I have access to the variable s, and I can see what it is. And you can also see, and this is why I mentioned this earlier, you can see that this gives me an overview of what variables are defined. So the variable s is defined, for instance, and has the value 0. I can also put a breakpoint here if I want, press continue, and then it hits this breakpoint, and now we can see that k is also defined. Then if I put in a breakpoint inside the while loop, which I have now, it'll just stop at that breakpoint. And I can put maybe a breakpoint more here. And that allows me to check what value term has. So it's sort of frozen what the expression does. And I could, if I wanted to, I could have experimented with this expression and sort of build it up piece by piece by just writing the lines in the debugger, checking what they did, check that I didn't have syntax errors, and then eventually, when I was happy, I'm doing key up here, so if you press key up, it repeats the earlier line. When I was happy, could have taken the line, copied it, then I could have inserted it here, like this, if I wanted to. Oh, I didn't get the entire line, so that was a mistake. And this is actually a very, very powerful way of writing code, because you can interactively see what variables you have available and what your code is doing within the script. So that's why the debugger is so powerful. Anyway, now we add term to s. Oh, now you can see, because I edited the files, the breakpoints are grayed out. That's the bad thing about the debugger. It doesn't work that well when you edit files and then press save, then you need to restart. So let's just restart. And now we press debug again. You can see now it's selected the debug option as the default. There's a little bug here, that's what it shows. And now we can remove some of these breakpoints because we no longer need to stop down here. So we jump up here. Let's also remove that. And now we go here. Press next. Now we got term defined. I go back to the debug control. Just check it. And then we can go to the next line, and that should update s. And you can see how your variables change their value over here. And then what you can basically do is you can maybe insert a breakpoint here just for fun. And press run. And now it terminates the loop. You can see s has this value, and it will fall. Now if I insert a breakpoint here and I press play again, it'll end up on this value here, and s still has the value it has now. So let's try to use all of this to solve the exercise, because I need to multiply this sum with this expression I have out here, 2 times square root of 2. So how can we do that? Well, we have s, and then we multiply it by 2 times the square root of 2. We can do that by using math.squared, like this, divided by 9,801. 9,801, like this, and we multiply all of that stuff to s, like this. That gives me a number, so we can maybe call that number for pi inverse, like this. And now let me just run this code. So I'm copying the code. What I'm basically doing here is I'm selecting it, and then I'm copying it by pressing Control C. So in all computers you can copy stuff by pressing Control plus C. So copy, paste. Paste is, by the way, Control plus V. Paste. Super useful commands to know. Like this. And you can see that this correctly defines the inverse of pi, and then I guess that pi would be equal to 1 divided by the inverse of pi. And let's check. It looks correct. So I'm happy. So I'll just take this line, copy it, and insert it here. And then I guess I need to return it like this, like I need to return pi. And then I can remove this, and now I'm done. So this is how this is actually how I write most of my code. I'm just sitting here in the debugger and playing around and copy pasting lines back and forth until I'm happy. And at some point I call it a day because it looks like I got the right output, pi. And then I save it. Let me just show the shortcut. Control plus S, that's save. Stop the debugger. And then we can just check it again. And now we can see that I solved the exercise. So that's basically it. That's how you use the debugger to solve an exercise like this. I'm going to return a lot to the debugger, I think, and explain it many times during this course, because in my opinion, it's a super helpful and powerful tool in order to get a correct implementation. So let's stop here.